Hi guys, welcome to Data Analytics with Python course. In this course, we're going to be learning data analytics using Python programming language. We'll be using mainly pandas for reading datasets and performing statistical analysis, as well as Matplotlib um, for data visualizations. So we're going to be using Matplotlib to generate scatter plot, histograms, or other charts. When it comes to the programming environment, we're going to be using Google Colab. It's an open source web-based Python IDE. Therefore, there is no specific software installations required for this course. Meanwhile, for our dataset, we're going to be getting datasets from Kaggle. There are lots of free and high quality datasets available on Kaggle. So in this course, we're going to be picking two datasets from two different fields to be used as a practice dataset. Before moving any further, let me introduce myself. My name is Chris, and this is my second course on Udemy. Previously, a month ago, I created a course related to AI print-on-demand business models. A little bit about myself. Previously, I worked as a technology risk consultant, and regularly I used several different Python libraries, such as NumPy, pandas, Seaborn, Matplotlib, and TensorFlow occasionally. Alright, so let's move on to the next slide. So, okay guys, here's the highlight of the course. First, we're gonna be discussing like whom this data analytic course is intended for, like what's the main prerequisites of knowledge or basic skills that you need to have, who are appropriate to take this course, something like that. So second, we're gonna be discussing what is Kaggle, right? So we're gonna go over its functionalities or features of this platform, and also definitely go over how to get datasets from Kaggle for completely free, how to pick datasets on Kaggle, stuff like that. So third, I'm gonna be introducing you programming languages, libraries, and other tools that we're gonna be using for this course. Um, Fourth, we're gonna be searching our first dataset on Kaggle. So as I mentioned previously, we're gonna be picking two datasets. So like both datasets we're gonna be getting from Kaggle. So that's the fourth section. The fifth one would be setting up your Google Colab programming environment. So I'm gonna guide you step by step how to sign up using your Gmail account or Google account on Google Colab, and then setting up your programming environment, right? So the next one will be uploading datasets and importing all necessary libraries. So like once you downloaded the datasets from Kaggle Bank, we're gonna be doing next is simply just to upload your datasets on Google Colab Python IDE. Then point seven, simply just we're gonna be performing or statistical analysis or data analysis on dataset one. And 8 is actually a repetitive of the point 6. So we're gonna be doing the same. We're gonna be looking the second datasets on Kaggle, and then point 9 is the exact same thing. We're simply just going to do the statistical analysis, perform our data analysis on dataset 2. Okay, so last but not least, since this course is intended for beginners, I would like to emphasize that I'll guide you step by step from setting up your Colab programming environment, finding the dataset of your choice on Kaggle to perform your data analysis on Colab. So I promise to explain you its code line by line in order to make sure you understand how its line of codes work. Yeah, I think that's it guys for the first video. Once again, I'd like to welcome you to the course and thank you for your trust to learn with me. I'll see you in the next video. Oh, welcome to the second video guys. In this video, we're gonna be discussing whom this data analytics course is intended for. So first of all, I'd like to make it clear, this course is definitely for beginners, as I mentioned previously in the previous video. Therefore, I'm not expecting you guys to have very advanced knowledge in Python. As a matter of fact, I'm simply just expecting you to have very basic knowledge in Python, understand very basic syntax of Python. So I can guarantee you there'll be nothing too advanced here. That's the first one. The second one would be, I'm not expecting you to have experience with pandas or Matplotlib previously. Again, I will put my foot on the shoes of beginner, so I will try to do my best to explain it from the perspective of beginner, from the perspective of someone who have very limited knowledge in Python. I'll try to do the best of my ability to explain the code line by line. So I'll make sure that you guys understand like how its line of code worked, stuff like that. Okay, then the third one would be this course is obviously intended for a Python beginner who are planning to specialize in data analytics or data visualizations, right? Because Python, I'll say Python is the easiest programming language to start, especially if you're new to coding. And Python is very broad, like there are lots of things, there are limitless of opportunities you can do with Python, right? You can do machine learning, you can do data science, data analytics, you can do web development, right, using Django. Um, there are like lots of things you can do with Python, and one of many things that you can do with Python is data analytics and data visualizations. Um, so if you're interested in uh, data analytics, and you like to learn more about how to perform statistical analysis, data visualizations using Python, and definitely this is the right course for you. The other one would be, okay, so I totally understand. Maybe there are like lots of you guys who are coming here, planning to get a entry level job in data analysis or data science. This is definitely the course for you to begin. This course is intended for beginners, so again, disclaimer: I'm not trying to guarantee you that after taking this course you're gonna be able to be data science expert. That's just not gonna work, right? This course is for beginners. This course is intended for people who have very limited knowledge Python to get comfortable, exploring data sets, performing, many different statistical methods using pandas and Matplotlib. So I'm not expecting you to be like very expert in data science after finishing this course. However, I can guarantee you that you're gonna be having a very solid understanding and a very solid basic to intermediate skills on like how to perform data analytics, right? Data visualizations, how to generate scatter plots, how to generate histograms or bar plot, right? How to calculate mean, median, average, max, min, stuff like that using Python. So yeah, that's definitely a right course for you, especially if you want to build up your portfolios. It's very important, especially if you're new to this field. If you want to get an entry level job, most of the times, if not always, your future employers will ask you to provide your, let's say, GitHub link. GitHub is simply just like a platform where most developers store their portfolios. So again, by taking this course, you're gonna be comfortable exploring datasets, and then do lots of experiments with datasets, and then you can store it in your GitHub accounts, and then definitely it's going to be positive contributions when it comes to your job applications when your employer see like what you've done with the dataset on your GitHub. They're going to get like more convinced that you're the right persons. So yeah, this is definitely the right course for you if you want to build up your portfolios. And here, the last point, last but not least, if you're interested in exploring Kaggle, and you might want to prepare for a Kaggle data competition, this is also the right course for you. So again, disclaimer: I'm not going to emphasize heavily on Kaggle. We're gonna be picking our datasets from Kaggle. However, Kaggle is definitely not the main thing in this course, right? But at the end of the course, after finishing or practice with two datasets that we're gonna be getting from Kaggles, I'm also going to have like one slide, I think, like the last one, to discuss specifically about Kaggle competitions. There are lots of rewards in Kaggle data competitions. Uh, if you win the competition, you're gonna be able to get a lot of money from the competitions. However, it's very competitive as well. So again, it's very competitive, and your chance to win is relatively low, I would say. But yeah, definitely, in my personal opinion, it's worth to try. Especially if you have always been interested in data and would like to, improve, develop your skills. Participating in data science competitions hosted by Kiko is definitely one of the most effective way to go, because you're improving your skills, um, but also you have you have a chance to win the competitions, right? Even if you lose, even if you don't win the competitions, you're not wasting your time, you're not wasting your energy, because you're getting a lot of skills, right? So yeah, that's one of the last thing that we're going to be discussing in the last slide. But again, this course is not too heavy on Kaggle. This course simply just using Kaggle as a platform that hosts like lots of data sets. So we're going to be picking our data sets from Kaggle. Yeah, I think that's it. I don't have any high expectations on you guys when it comes to your Python knowledge, right? I will try to do my best to discuss and teach from the perspective of a beginner. So yeah, I think that's it for this video. I'll see you in the next video. In the next video, we're gonna be discussing like what is Kaggle, and I'm going to go over like each sections of Kaggle that you guys might need to know in order to be able to succeed. Okay, so I'll see you guys in the next video. Alright guys, welcome back to the course. And in this video, we're gonna be discussing mainly about Kaggle. So let me, okay, go back to the slide and have a slideshow here. Alright, so to answer this question, what is Kaggle? Kaggle is basically a data science learning platform. There are like many features in Kaggle. There are like free courses or classes on Kaggle. Competitions. Kaggle regularly hosts many different data science, data analytics competitions. Kaggle also has dataset banks, discussions or forums. So if you're stuck and uh, not able to find solutions to certain problems, and then you can go to discussions forum on Kaggle. There are lots of people might have the same issues or might have the answer for your questions. So go there, post your questions there. That's a science portfolio too. So Kaggle also hosts like lots of data science portfolio, people uploading their codes, mainly um, projects related to data science on Kaggle. So yeah, that's what Kaggle is. Again, disclaimer: I'm not affiliated with Kaggle. Okay, so I'm not sponsored by Kaggle. I simply just use this platform because it's a pretty good platform to be used to learn data science. Again, this course is not too heavy on Kaggle since I'm only going to be using this platform to get our free and high quality data sets. Okay, so let's go to Kaggle. Oops, I pressed the wrong button. Okay, so let's go to Kaggle. So all you guys need to do is simply just go to the kaggle.com. So this is the dashboard of the website. I think you guys can sign up. I actually already logged in here using my account. I don't think you guys need to create your account manually. You can simply just link your Kaggle to your Gmail account, and it will directly link it. So yeah, just log in or sign up if you have not created your account yet by linking your Google accounts, your Gmail accounts to Kaggle. Okay, so this is a dashboard. Kaggle has competitions section here. There are like lots of active competitions. But we're not gonna be discussing Kaggle data science competitions right now. We're gonna be discussing these competitions in the last slide. All right. So Kaggle also has datasets. This is the sections where we're gonna be picking our datasets. Kaggle also has this is code sections where people uploading their projects, mainly data analytics, data science related projects, to Kaggle, and then it's free to access. There are lots of like varieties of projects here. This is trending sections, projects that are currently trending right now, data cleaning, learning curve. So basically, you can find lots of different type of data sets here, and also projects that people have uploaded here. There are like lots of filters tools here that you can use um, to find the one that you're looking for. It's not only limited to Python. People also use R occasionally, even though Python is definitely more popular compared to R. But there are lots of people to use R on Kaggle. So if you're interested in R, then yeah, it's pretty easy to find projects using R programming language on Kaggle. This is the discussion or forum sections. I'll normally say, yeah, there are like lots of questions. So if you guys have any questions, if you guys are stuck on the problems, this is definitely the sections to go. There are lots of other people might have the same issues, or they might have the answer for your questions. So go here, try to find the one that you're looking for. If you're not able to find, then post your questions for completely free here. Yeah, many different questions, most of them related to like syntax or maybe any other technical questions, something like that. And then Kaggle also has free courses available. So they have mostly like Python course. They also have SQL, right? So many different courses here you can access for completely free. You just need to sign up here to this platform. Yeah, I think that's it for Kaggle. That's it for Kaggle. I'll also going to be provide the link kaggle.com on the slide, so you guys can simply just click on the link, and then it will automatically direct you guys to the website, to the Kaggle website. All right, so yeah, I'll see you in the next video. In the next video, we're going to be talking about tools that we're gonna be using, like Python libraries we're gonna be using, Matplotlib, pandas, and other tools or Python libraries we're gonna be using on our projects. All right, so I'll see you guys on the next video. Bye. Alright guys, welcome back to the course. In this video, we're gonna be discussing about tools that we're gonna be using. First of all, we're gonna be using Python version 3.0. When it comes to Python libraries, we're gonna be using mainly pandas and Matplotlib. Pandas is intended for statistical analysis and reading our dataset. Meanwhile, Matplotlib is intended for data visualizations. Because in this project, we're gonna be generating many different graphs, scatter plot, histogram, or bar plot. So that's the reason why we're going to be utilizing Matplotlib in this case. The next one would be Kaggle. As mentioned previously, we're going to be obtaining our datasets from Kaggle. We're going to be picking 2 different datasets from Kaggle, datasets bank. And here, last but not least, we're also going to be using Google Colab / Jupyter Notebook. Okay, so you guys can choose like either one. I personally chose Google Colab for some reasons. But again, Jupyter Notebook also works pretty much the same way as Google Colab. Jupyter Notebook is extremely similar to Google Colab. So if you guys are more comfortable with Jupyter Notebook, feel free to pick this one. Again, as mentioned previously in the previous video, there will be no installations, there will be no software installation required for this course, since Google Colab is an open source Python IDE. So everything that you guys need to do is going to be available on your browser, right? You guys just need to go to Google Colab and sign up using your Gmail or Google account there. Okay, so I think that's it for this slide. Let's move on to another slide. Okay, so datasets that we'll be using. I personally picked 2 different datasets. The first one is Uber Ride City to Airport or Airport to City, vice versa. The The second one is movies rating and statistics by IMDb. Okay, so if you guys see, if you guys notice that I picked two different datasets, and those two datasets are not related to each other, right? The first one is related to like transportation's niche, and the second one is related to like movies or entertainment niche. So again, my main goal here, my main motivations here by choosing two different data sets from two different fields, because I want to make you guys comfortable, exploring data sets from as many field as possible. Because like data sets from like different fields definitely have like different nature, and most of the times, if not always, would also require you to have like different approach. So like the more data sets you're using to practice, I'm pretty sure and pretty confident to claim that you're going to be more proficient and like have more experience when it comes to um, exploring this type of data sets, right? So okay, so this is just these are just additional notes. For further practice, feel free to pick any datasets that you're interested in. There are many filter tools available on Kaggle, which hopefully ease your process to find the one that you're looking for, the one that you're interested in. We'll also go over to the filter, so don't worry guys, I will guide you step by step how to find datasets of your choice on Kaggle on the next video. So again, the thing that I would like to emphasize here in this video, I'm picking these two datasets because I'm interested in these two datasets, but again, you guys can pick any datasets that you want. The approach might be a little bit different, but the concept, like the basic concept, are going to be exactly the same. So if you feel comfortable with Python and pandas, Matplotlib, stuff like that, and would like to experiment by picking different datasets, feel free to choose any dataset that you're interested in. Or maybe if you're really like beginner, you have like very limited knowledge, then it's definitely very recommended for you to simply just pick these two datasets that I chose here, and then go step by step. And after finishing this course, pick another dataset of your choice, another dataset that you're interested in, and then apply the same exact concept to the dataset. That's the effective way to test your knowledge, the effective way to test your skills, whether your skills have improved after taking this course, right? So yeah, I think that's it for this video. I'll see you in the next video. It's going to be like more technical, so yeah, please be prepared. All right, I'll see you guys in the next video. Alright guys, welcome back to the course. I would say this video is going to be the first video that's more technical than the previous video. So let's start. So in the PowerPoint slide, I leave this link so you guys can click on this link. But since I have already had my kaggle.com available on the other tab, so I'm not gonna click on this link. I'm just going to go to other tab, kaggle.com. So first thing that we need to do is go to the sections. Sorry, not competitions, it's dataset. All right, so from dashboard, all you guys need to do is just click on datasets. Okay, so since I'm interested in Uber data request, Uber request data, so just type in on the searching engine, and then okay, so it seems like this is the right data. Okay, cool. So all we need to do is just go to the download button here and click on it, right? Okay, so it's downloading, and then show in Finder. Okay, so now it's available here in our download folders. Okay, cool. I think I've downloaded the first dataset. I think we're going to be downloading the second dataset later on. I'm just going to go back to the dataset sections here, and then I'll teach you guys how to find datasets that you're interested in. Because there are like lots of datasets available on Kaggle, very high quality and also free to access datasets. So again, Feel free to pick any datasets that interest you the most. um, so there are like lots of tools here to filter out like what data sets that you're looking for. You can filter file size here, maximum minimum size here, because sometimes you don't want to be dealing with very large data because it will take a while for your code to compile. Or maybe you want to choose a certain type of data like CSV only. You can just click on it, so the searching engine will automatically exclude like data that there are the data sets that are not in CSV form. Yeah, you can also filter out by the license, Creative Commons, meaning that you have the right to reuse it. So okay, so these are most likely like the license of the data, like the permissions given by the authors, where you can use the data for certain actions or not. Um, so those are the main filters here, but you can also find the trending data sets. So if the data has very high usability rate, like this is 10.0 or maybe like above 8 in general, usually it will appear on the top here as like the main recommendations. If you like to explore more about like what datasets are currently trending right now, just click on this button, see all, and then it will directly bring you to this page. Okay, scroll down. You know, there are like lots of datasets are currently trending right now, and I'm not sure if this is very accurate representations of the quality of the datasets, but most of the times, what I normally do is simply just see the usability. So the usability is actually kind of like a rating or scores that these datasets got based on its quality. So um, again, I'm not saying if you see like dataset with like very like low usability, it means the dataset has very low quality. But I would like to avoid any dataset that has usability scores lower than 6, just to be safe, in my personal opinions. But again, if you guys want to explore, then yeah, completely fine, right? Do whatever you want. Yeah, I think that's the trending data sets. If you scroll it down, you can also find different data sets from different needs. Movie and TV shows, right? Mostly related to like Netflix. As a matter of fact, the second data sets that we're gonna be picking for this course is actually coming from movies and TV shows too, right? Recently viewed data sets. It's simply just the history of data sets that I viewed in past couple days. Clothing and accessories, more like e-commerce stuff like that. Economics. So if you guys are interested in data related to economics, right, finance, just go here and click see all, and then find out like what you're interested in. NLP, it's more like advanced data sets. NLP stands for natural language processing. It's more like deep learning stuff. So again, it's definitely not for beginner. So if you guys have solid knowledge in Python, deep learning, machine learning, then go here. Feel free to find um, lots of data sets for NLP projects, right? But it's definitely not for people who have limited knowledge in Python. This is more like medical data related to cancer, like predictions. Also pretty advanced stuff here, because in this data we're gonna be learning, not learning, we're gonna be applying knowledge related to like imagery recognition. So it's obviously very advanced stuff here, not recommended for beginner in my personal opinion. um, this is data related to COVID or healthcare or anything related to health. um, okay, so yeah, think that's pretty much it. If you guys want to filter something, just click on this options here. For example, if you want to get the data related to NLP, just click on this, and then it will give you like lots of data related to NLP, right? Or if you guys are not able to find data that you're interested in, simply just type in like the keyword here, what you're looking for. For example, you're looking for data related to Netflix because you want to do analysis on something related to Netflix, right? You want to have projects related to Netflix. Just click on Netflix here, enter, and then it will present you with lots of data related to Netflix, right? And then yeah, you can filter out by most votes, new, updated, usability, right? So for example, you want to rank the data sets um, based on the usability score, right? From high to low, just click on the usability and it will present you the Netflix data that has very high usability. Yeah, or maybe the new one, right? You want to find data, the most recent data uploaded to Kaggle datasets bank, then just sort by the newest one, right? Yeah, I think that's it. I think that's all you guys need to know, like how to find datasets that you are interested in or datasets that you're looking for. There are lots of datasets here, so if you guys are very interested in datasets, just go here and then there are limitless amount of datasets, I would say, that you guys can find here. Yeah, I think that's it for datasets discussions on Kaggle. In the next video, we're going to be setting up our Colab, Google Colab environment, right? We're gonna be setting up our Colab environment. I'm going to teach you guys how to set up on your browser. So again, no installation required. You guys simply just need to like sign up using your Gmail account. That's pretty easy and pretty straightforward steps. Nothing too complicated. Okay, guys. Anyway, thank you. I will see you in the next video. All right. I'll see you in the next video. Alright guys, welcome back to the course. In this video, actually it's going to be a pretty short video here because I'm simply just going to explain you step by step how to sign up, create your account on Google Colab, link your Gmail account, and yeah, set up the programming environment, right? So all you need to do is simply just go to this link, just click on this link, but since I have this already available on the other tab, so I'm simply just go to this tab. So first thing we need to do is just sign in, right? Click on this button, sign in. Okay, so now it seems I have signed in here. Okay, cool. You can do the same thing using your Gmail account, link it to the Colab Research Google. Okay, so now if you have already signed in, simply just go to file here and then click new notebook. Okay, new notebook. Okay, apologize because my internet connection doesn't seem to be very stable. It takes a while. Okay, so now you can rename it. Okay, so you can rename it. Personally, just going to rename it using the name of the datasets that we're going to be using. So it's going to be Uber data analysis. That's how I'm going to name this project. So if you notice that at the end of the name of this file, if it's just like a normal Python, it's just a normal Python file. It's going to be just like .py. But in this case, it is IPYNB because this is not a normal Python file. For your information, this is Jupyter Notebook Python file. So it's basically Python with Python syntax. But if you upload this on GitHub, it will not fall under category of Python. Instead, it will fall under category of Jupyter Notebook. Okay. So yeah, I think that's it. Now you can close this tab since we are not going to use it anymore. And congratulations, you have just set up your Colab Python IDE. Okay, so no installations required in this case. Everything that you need to do is right here on the browser. Okay, so now you can type the code. Okay, let me test it out. Import pandas. spd, something like this. Just test out if it works well, right? So we're just going to like write down like random code here. Yeah, maybe just create a list one, declare it to be like a empty list, and list one equals to 1, 2, 3, 4, and 5. And then maybe we want to get the mean or the average of this list, right? SNP and then we're just going to print the mean. See if this works. Again, apologies guys, my internet connection doesn't seem very stable right now, so yeah, it might take a while for the code to compile, but again, I will promise you guys next video I will figure out like what's going on with my internet connection, so it will compile quicker. Okay, so cool. So the average is 3. Yeah, I think this works well. So I will see you guys in the next video. In the next video, we're going to be doing the actual data analysis. This is simply just to test out if it works well. Okay, I'm going to get rid of all these codes and then compile it again, and the output is supposed to be empty. There's supposed to be no output here. Okay, cool. Yeah, it simply just indicates that this works well. Okay guys, I'll see you in the next video. Bye. Alright guys, welcome back to the course. In this video, we're going to be starting to code. Okay, so we're going to be doing our analysis. Alright, so since we have downloaded the datasets, the Uber datasets previously from Kaggle, and we kept that dataset in download folder, so now it's the time to upload it to Colab Python IDE. So let's write the code. Okay, so first from Google Colab, google.colab, import file. So this is the code is being used to import or upload a dataset to Colab Python IDE environment. And then let's create a variable called uploaded. You can name it whatever you want. Files.upload, open and close parentheses, and then let's run. Okay, so I think all we need to do is simply just to click on this button, choose files, and then since we keep it in the download files, so let's go to Uber request data and open. Okay, so since the size of the dataset is not that big, so hopefully it doesn't take too long. Okay, actually it has been uploaded, so it only took like less than 3 seconds. Let's create another block of code. Guys, thing that I like the most from Google Colab is the fact that you can have like many different code blocks and then run it like it's one by one separately. So yeah, it's pretty cool functionality in my personal opinions. So let's test it out. Okay, so import pandas spd. This is the libraries, one of the libraries that we're going to use. Pandas. So I would say like 70 to 80% of like the whole project going to rely upon this library pandas, since we're going to be conducting statistical analysis and reading our data sets using pandas library. So let's read the data. Since the data has been uploaded, so it's now available to use, all we need to do is simply just create a variable. I name it data, some people call it df or whatever. You can name it whatever you want, as long as you're consistent with the name. You should not find any issues. So here is the syntax: data equals to pd read.csv, and then open and close parentheses, and then since the name of the data sets that we use is Uber request data, so just type it in here, Uber request data .csv. Okay, so this is the variable that we use as the data a variable that represents the data that has been uploaded. You can name it whatever you want. And pd.readCSV. PD is an attribute of pandas library, and read CSV is simply just a command to read whatever data sets that you have, and then it takes like one parameter only, which is a string of the name of the file. So like in this case, the name of the file is over request data, so that's what we put it here. And to get like basic informations of like what the data looks like, you can use head attribute. So data.head like this, and then see what the data looks like. Right, looks pretty cool. Yeah, so yeah, you guys just need to be consistent. So for example, if you name it df and then you compile it, then it will, if you compile it, you also need to have df here connected to head, right? Gotta be consistent. Okay, cool. That's the head, like the first 5 rows of the data. What if you want to see like the last 5 rows? So you simply just change it from head to tails, and that's going to give you like the last 5 rows here. Okay, cool. Okay, so we're just gonna leave it to be like this, or maybe 5 rows are too many for you guys. Maybe you just want to display like the first 3 rows, so just put 3 as a parameter, and then that's what you got there. Okay guys, I think that's it. Why don't we just create another block? Let's get basic informations of the data. So import pandas spd. Yeah, as usual. Actually, if you have already written down like import pandas spd here, it's not necessary to rewrite it again. However, this is just like one of my habits, but again, it's not necessary. So let's type in data.info and then run. Okay, so actually what this code does, it provides us informations about data, like the data type. For example, request id, the data type is integer, meaning it's number, but it's not decimal, it's like a round number. And pickup point, it's an object. Driver id, it's a float, it's a number. Pretty sure if you guys know basic Python, float is decimals, basically like a number. And what makes it different from integer? Integer is round number like 25, but float is decimal, so it can be like 25.0. It also can be like 25.7, something like that. Status object, request timestamp object, drop timestamp object. So it's actually pretty helpful for you guys to just type in data.info here, and you get like the basic informations about the data sets that you guys are working on, right? Yeah, it's pretty useful to know, because sometimes if your column is based on, let's say, a string, and then you need to calculate the median or max mean, then you won't be able to perform that command, because you cannot do any calculations with string, right? You need to convert it to float first, or to integer first, in order to be able to do the calculations. Okay, so the next one, why don't we just display like the shape of the data? If you're curious, like how big is the data, right? You might be wondering like how big is the data. So the comment that we can use here is data dot shape. Okay, so in this case we don't need to use like open and close parentheses. Okay, so it means that these data sets consisted of 6,745 rows and 6 columns, right? So like 1, 2, 3, 4, 5, 6 columns and 6,745 rows. Yeah, it's pretty useful to know. Again, it might not be necessary to be displayed here, but this is just like part of my habits, just to see like, just to get like basic informations of like what the data looks like, data info, data shapes, and data head, data tail. Maybe if you're curious, like what it looks like the last 3 rows, the last 5 rows. Um, yeah, I think that's all you guys need to know when it comes to seeing the overview of your data sets. Like make yourself comfortable and get used to the data that you're going to be working on. In the next video, we're going to go a deep dive into the actual analysis. So this is simply just like the introductions with very simple codes. um, yeah, I'll see you guys in the next video. Welcome back to the course, guys. In this video, we're going to be doing more complicated stuff. So, yeah, definitely this video is going to be a pretty long video. Just in case you guys haven't had your snacks or maybe coffee and tea, get them ready by now. All right. So, without further ado, let's start. Okay. So, if we notice here, the second column here is a pickup point, right? So basically there are like two different trips in these data sets. The first trip is from airport to the city, and the other one is the exact opposite. So from city to the airport, right? Um, okay, so if the questions was asking like which trip is more frequent, right? From city to the airport or the opposite, from airport to the city. Okay, so let's figure that out. Okay, so now let's import pandas first. Because pretty sure that we're going to be using a lot of attributes from pandas library. So let's get it ready first. Okay, so now let's count using this code data dot value underscore counts, open and close parentheses. So this particular syntax takes one parameter, and that parameter is the name of the column as a string. So all we need to do is simply just get the name of the column, which is pickup point, and copy and paste it right here, and then compile the code, and then we'll see. Okay, so it seems like there are like 3,507 trips from city to airport recorded. Meanwhile, there are 3,238 trips from airport to the city. Okay, so if the question was asking like which trip is more frequent, then the trip from city to the airport is more frequent compared to the trip from airport to the city, even though this difference is not that significant actually. Okay, so the next question might be, what about the percentage? Okay, we knew that the trip from city to the airport is more frequent, but what about if we are curious about the percentage? Okay, so let's do the calculations to get the percentage. Actually, the syntax is very similar. Why don't we just copy and paste the code? However, we're going to type in city here and airport on the bottom. Okay, let's compile the code and see what happened. Okay, cool. So now we already got the answer. The percentage of the trip from the city to the airport is 51%. As you can see, this is decimal. It's 0.51. Meanwhile, the trip from the airport to the city is 48%, or here it was displayed as decimal. It's 0.48. Okay, so again, we already knew the answer to that questions. There are definitely more trips, more frequent trips from city to the airport compared to the trip from airport to the city. What if we want to see it in a more obvious or better way, so we can get like more solid understanding? Why don't we do data visualizations? Okay, so when it comes to data visualizations, this might be the first time we use Matplotlib. So let me import Matplotlib first here. dot pyplot as plt. Okay, cool. And now we're simply just going to copy and paste this code again, and we're gonna add something else. So we're gonna add plot dot var, open and close parenthesis, and don't forget to add plt.show. Okay, don't worry, I'm going to explain the code line by line, so don't worry. We're just going to compile it first, and then this is the plot bar that we got. Yeah, it looks it looks makes sense, right? Because the city is a little bit the trip from the city to the airport is a little bit more frequent compared to the trip from the airport to the city. That's why the bar is a little bit taller compared to the another bar that represents the trip from airport to the city. Okay, so let's discuss about the code here. So basically, we use plot bar. It's simply just a attribute of Matplotlib to generate a plot bar. Okay, so what this particular part of the code does is to generate plot bar, and then the pltco, I think it's optional. Like, you guys don't need to use this if you guys don't want to. That's just part of my habit to use it. Simply just give like a clear command that, hey, show the graph, something like that. Even when I get rid of it and then you compile it, it still shows the exact same graph, right? But it's better practice to simply just have this, because it doesn't take too long to just write this piece of code, right? So okay, so I think we got the answer for that particular questions. So why don't we move to another part? Notice that the column beside pickup point, it's driver ID, right? So why don't we play around with driver ID and see what we can do with driver ID column. So why don't we just do the exact same thing first here. Okay, so let's import pandas as PD as usual. And now this time, the parameter is going to be driver ID, right? Let me make sure if I type it correctly. Oops, the ID is supposed to be in lowercase. Okay, so now I've fixed it. Let's compile the code and see. Okay, so simply just this data is just a representations of which driver has the most passengers, or like which driver has the most frequent rides with Uber. So these numbers, like these numbers on the left, 27, 176, 177, represents the driver ID. It's simply just an ID. It doesn't represent anything but ID. Okay, so 27 is, let's say 27 is A, 176 is B, 177 is C, or just like different driver. So based on this data, we can take a conclusions that driver ID 27 is the one who has the most passengers, or the one with the most frequent trips. Okay, so next, why don't we do something different here? Okay, so I'm going to do the same thing again for pandas SPD. Oops. Now we're going to use data group. Don't worry guys, I'll explain it once I'm done writing the code. So let's do it. Okay, so we're going to have two different parameters. The first one will be driver ID, because that's the column that we want to compare, and the second one would be pickup point. So these particular functions, data.groupby, can take two different parameters, and the purpose of using this code, like what does this code do, is simply just to compare, like show you like comparisons, right? Or show you like relationship between these two columns, stuff like that. Yeah, hopefully if that makes sense. So I'm just going to copy and paste this. I'm too lazy to type, to be honest with you guys. I really apologize, but here we go. I forgot the quotations mark here. It's supposed to have a quotations here. Okay. um Now I'm just going to type size. So what it does, simply just to show like the relationship between driver ID and pickup point. And let's compile it so you guys can see like what's going on here. Okay, so simply just this code simply just display like the driver ID and the pickup point, like the relationship. For example, driver ID 1. For example, me myself um has has driver ID 1. So this driver ID 1 represents myself. In total, I have 13 trips. Makes sense, right? So 7 trips from airport to the city, and there are 6 trips from city to the airports. Or maybe my friend is driver ID 2. In total, he also has 13 trips. 7 trips from airport to the city, and another 6 trips from city to the airport. Okay, so yeah, that's how we display informations regarding like relationship between two columns, right, by using this particular code. Okay, so let's use something different here. Let's do something different. Why don't we play around with status? Okay, so that don't worry, we're not going to leave this code, because I know like most of you guys might be still wondering like what can we do more with this particular code. We're going to combine it, but step by step, so hopefully it's not gonna make you confused. Okay, so let's play around with status. Okay, let's play around with status. So let me scroll up a little bit. Status is on the right side of the driver ID. So there are like 3 types of status if I'm not mistaken, but let me write the code first and display like what's going on here so you guys can see like what's really going on. Okay, so um, we can copy and paste again this code, and then instead of having driver ID, we're just going to have status here and see how many different types of status stored in this data set. Okay, so it seems like there are 3 types of status. Trip completed, meaning that, it's pretty self-explanatory, right? Trip has been completed. So, for example, a trip from a city to the airport, or the opposite, from airport to the city, has been completed, where the passenger has been taken to the airport and arrived safely, and the payment has been made, something like that. No cars available, meaning that when me as a passengers, I was ordering Uber, but no cars available for me. So automatically by system it got cancelled. So there was no payment being made, and there was no trip. That's what no cars available mean. And cancelled, meaning that, okay, so I was ordering Uber from city to the airport, for example. I'm trying to cancel my flight. Okay, the app in my phone shows or indicates that actually I already got a driver. However, maybe due to some issues, perhaps, for example, there is a problem with the car. The car needs reparations, and the driver unfortunately uh, canceled. Then again, there was no trip, and there was no payment being made here. Okay, so why don't we analyze the status column? Okay, so from these data sets, let's play around with statistic a little bit. So we're just going to copy and paste these 3 times, because we knew that there were like 3 different types of status. So first, because we want to know the percentage, right? Because we know that, okay, the most common status is trip completed, which is not surprising, right? I mean, it will have been a problem if this is not the highest statistic here, because it seems like the service is bad, right? The second one is no course available. And the third one is canceled. Again, everybody has different perspective, but me, if I'm a product manager of Uber and I'm trying to analyze the data pattern here, based on this data, I'm not saying like I'm satisfied with the performance, but um, the main objective that we all need to be trying to accomplish here is to make sure that the trip completed has to be as high as possible and the canceled has to be as low as possible. The same thing with the no cars available, it needs to be as low as possible. That's how you maximize profits. But again, I totally understood the fact that there are like too many external factors going on. So it will be like easy to say it in theory, like that's what we want to achieve, but in reality, um, actually that's not that easy, right? So yeah, let's analyze the percentage first just to see if actually the trip canceled is that significant or maybe it's not that significant. We have no idea, right? Okay, so I forgot to add C here. Then we compile it. Okay, so now we got the percentage. The code right here is exactly the same. Oh, sorry. Is exactly the same like the code right here. Simply just calculate the percentage. Okay, so the trip completed is 41.9%. The no course available status is 39.3%. If I run that number up, the canceled status is 18.7%. So yeah, that's the percentage. Again, this is just my personal opinion. Everybody has different opinion, but I think when you see the number of rights being canceled is 18.7%, um, I see it as a pretty negative indications there is something wrong with the performance, right? Because if you're talking about canceled rate, I think the ideal phase it should be around like 5 to 10% will be an ideal. But anyway, I'm not trying to lecture you to be like a product manager or analyzing performance here. We're simply just learning basic Python's basic data analytics using Python, right? So we're not gonna go that far, I guess. Okay, so here now we have displayed the percentage of each status of the trip. So now we're going to combine the driver ID with the status. So why don't we just go a little bit up here and then copy and paste the exact same code here, because it's gonna be exactly the same, except we're going to replace this pickup point with status. Because previously what we did was to see like the driver ID with the pickup point, because we want to see like the relationship between driver ID columns, like the driver, and his or her trips, whether it's to the airport or to the city, and like how many trips for its road. Okay, so do the exact same thing, but this time for status, and let's see what's going on here. Okay, just pick an example, driver 1. So he has like 4 trips canceled. He has 0 no cars available status. He has 9 trips completed. What about driver 2? He has 4 trips canceled and 9 trips completed. Yeah. Again, I'm not saying like when the trip was being canceled then it must be a bad performance from the driver. That's not the case. However, it's definitely a positive indications when you see like when you see a driver has more trips being completed compared to trips being canceled, right? That makes sense, right? Okay, so let's move on. Why don't we conduct further analysis on the driver performance? Okay, so we are going to import pandas spd, and we're going to do something different here. Value counts. Driver ID. Don't worry guys, I'm going to explain it later on, but let me finish writing the code first. Okay. So what does this code do? Simply just to display like driver ID with the highest performance. The highest performance represented by the most trip completed. So in this case, when we see this, it looks like driver with ID 22 has 16 trips completed. So he is the driver with the best performance based on this theory, based on these qualifications, right? And then, if we see like people on the bottom here got like one trip canceled, they're left on the bottom here. If you want to see, let's say, the best three drivers, meaning that three drivers with the most trips completed, they're like 22, 233, and 184. Let's assume these three are three different drivers, right? Or maybe you want to see like which driver has the lowest performance. Okay, so just get rid of this and then go back to the initial display. Okay, so I think that's answering our questions when it comes to like the performance of the driver. If we analyze the performance based on the qualifications of status trip completed as the main requirement that needs to be satisfied. Okay guys, I know this video has been very long, so I guess I'm going to see you in the next video. We're still going to be conducting analysis, like different type of analysis, but I don't think it's good idea to have very long videos, so I'm just going to break it into like two different videos. So I'm going to have another video for this dataset practice. Okay guys, I'll see you in the next video. Alright guys, welcome back to the course. This is dataset 1 practice part 2. Again, since if I combine it with the first part, it's going to be very long video, so I guess it's definitely not a good idea to have very long video. So yeah, I break it down into two parts, so you guys are going to be able to concentrate more, hopefully. So this is where we left. Now we're going to be doing a little bit different, but still using the same concept here. We want to see the relationship between pickup point and status. So previously we were trying to find the relationship between driver ID and status in order to be able to analyze the performance of each driver. So now let's do something different. So instead of having driver ID here, we're just going to replace it with pickup point and see what's going on here. It seems like I mistype it. Okay, cool. Now it has been displayed here. So when we see and try to analyze pickup point, so when the trip is from the airport to the city, there are like 198 trips cancelled, 1,713 no course available, and 1,327 trips completed. But when the trip is from the city to the airport, there are like 1,066 cancelled, 1,066 trips cancelled. That's huge, guys. It's 937 no course available and 1,504 trips completed. Yeah, it's pretty good. However, if we see these numbers, I see there is something wrong with this sport specifically. Okay, so if you see, if we're talking about the trip from airport to the city, the canceled trip was only like 198. Let's round it up, it's 200. It's simply just like a pretty small percentage. It's not that significant if we compare it to the trip completed. But when the trip is from city to the airport, the canceled trips is 2/3 of the trips completed. I think that's a red flag, to be honest. When it comes to performance, it's a red flag. Because how come there are like so many trips getting canceled from city to the airport, right? Um, and the percentage, or maybe we're just talking about a number, not percentage necessarily, of trips canceled. If we compare the trips canceled from city to the airport with the trips canceled from airport to the city, there is like a huge difference, right? Just yeah, it just indicates there's something wrong, or something needs to be fixed here. Okay, that's my 2 cents on it, my analysis. And then maybe it'll be a better idea to just visualize the data. So let's import Matplotlib as usual, .pyplot. Okay, so we're just going to copy and paste this code, and we're going to get a plot bar here, plt.co, open and close parentheses, and see what's going on here. All right, awesome. Pickup point and status. Okay, so there are like 6 different bars. The first one represents the trip from airport to the city and got cancelled. It's not that significant compared to the others, only like 198 below 200. Um, the second bar represents the trip from airport to the city when the course is available. Okay, that's pretty high. Maybe it's the highest one. Yeah, it's the tallest bar here. The third bar represents airport to the city, trips completed. Okay, this is pretty good performance, I would say. The fourth one represents the city from, I'm sorry, the trip from city to the airport and get cancelled. Yeah, I think this is red flag. This bar needs to be highlighted, because you know it's almost like 2/3 of the trips being completed. Just doesn't make any sense. It's just like a pretty clear indication there's something wrong going on here. The fifth bar represents the trip from city to the airport, so no course is available. And the last one will represent city to airport when trips are completed. So yeah, I think by having a display of this plot bar, we're gonna be able to like see it further and analyze it in a easier way. Because if you compare it like airport to the city cancelled versus the trip from city to the airport cancelled, right? It's almost like 6 times. I'm sorry, 5 or 6 times more. Yeah, so I think we need to have like further investigations if uh further investigations like what's wrong with this, right? Okay, so let's move on. Um, let's move on. And now we're going to do pretty fun calculations here. No more graphs. Instead, we're going to do more statistical calculations here. Okay, so first of all, we want to display like the percentage of its conditions. Let's do the calculations. First, I will add up. I would sum up the total trips from airport to city. Okay, total airport. So total airport, so we add 198 plus 1713 plus 1377. Okay, and then the second variable is going to be total city. So this variable represents the total amount of trips from the city to the airport. So 1066, if I remember it correctly, yeah, plus 937 plus 1504. Okay, 1504. So now we're going to calculate the percentage one by one for each conditions. So first, canceled airport. This is the trip canceled from airport to city. So simply we just divide this number 198 divided by total airport. Since we want to display it in percentage rather than decimal, so we just need to multiply this by 100 because we want to display it in percentage, right? So no cars available, so because I don't really want to have like very long name or long variable, so we're just going to keep it like this, no cars airport. So this represents the amount of trips from airport to the city they're getting canceled due to no cars available. Okay, so 1713 divided by total airport. Don't worry guys, if you're not clear enough, I'm going to explain it like line by line after I finish these calculations. And the third one must be canceled. Canceled airport. Okay, so sorry, the third one must be a completed airport. So it's simply just like a trip that has been completed from city to airport. So it's supposed to be 1327 divided by total airport. Then you guys need to multiply it by 100. Okay, so that's enough from for the trip from airport to city. So now we're going to do the exact same thing for the other trip from city to the airport. Okay, so why don't we just copy and paste this and then change the number. So completed airport, cancel airport, we're just going to replace it with cancel city. The same thing with this city, the same thing with this too, city, and then use the number. So use this variable as a replacement for total airport because we want to make sure that we do the calculations correctly here. And total city is going to be 1066. This is the representations of total trips canceled from city to airports. It's going to be 197 and 137. This is going to be 1504. Okay, cool. So we're done. Let me explain you code by code. So the first one here, so okay, let's begin from the top. So the total airport represents the total amount of trips from airport to city recorded in this data set. Meanwhile, this variable total city represents the amount of total trips from city to airport recorded in this dataset. Cancelled airport represents the total amount of trips cancelled from airport to city. In percentage, no cars airport represents the trips getting cancelled due to no cars available from airport to city. In percentage, completed airport represents the amount of trips total amount of trips completed from airport to city in percentage. And these three are the exact same thing. Cancelled city represent the total amount of trips getting cancelled from city to the airport in percentage. No car city is the amount of trips getting cancelled due to no cars available from city to airport in percentage. And the last one here represents the amount of trips from the city to the airports being completed in percentage. Okay, so now let's display the number here. Okay, so print cancel airport, print again. Okay, so why don't we just copy and paste it 5 times? Because I'm too lazy to type, guys, to be honest with you. 1 2 3 4 5 6. Okay, awesome. So now we're just going to copy and paste the name of the variables like this. Completed airport. What else? Cancelled city here. No core city going to be here, and the last one will be completed city. So here, okay, awesome. Just compile it, and this is what we got here. Okay, so again, the main concern that we had previously was the fact that the trip from city to airport that was getting cancelled was very high, like 30% here. This number is definitely red flag. So if I'm like a product manager of Uber, this is definitely like one of the biggest concern that I have. Because if we compare it to the trip that's getting cancelled from airport to the city, it's only like 6%. Even 6% is pretty high, but again, it's still tolerable, still below 10%, right? So I don't think it's supposed to be a big deal. But trips getting cancelled from city to airport, 30.4%, if we're round that number up. Yeah, obviously there has to be something wrong with it, right? So okay, but again, we are not going to get that far. We're just doing analysis. We're not like trying to solve like business problems here. So I guess we're not gonna go to that directions. All right. Yeah, I think we're done with conducting this statistical analysis, statistical calculations. Why don't we add another block of code and do something else different? Okay, so let's scroll a little bit up here to see what's going on here. Notice that after this column, you have like the last two columns, request timestamp and drop timestamp, meaning that this is the time when the passenger is requesting the ride from Uber, and this is the time when the passengers has been dropped in the airport or in the city, right? Okay, why don't we do the calculations? We want to know the durations, right? We want to know like how long it takes from passengers from ordering Uber for a ride. Let's say, for example, from city to airport. How long it takes from typing in your phone in your app and trying to find a car to get you to the airport. How long it takes till you finally got dropped in the airport, right? So let's do it. As usual, import pandas SPD. Just a common practice, I guess. Before moving any further, let me go up here. That's the very important aspect why we need to have data info. Because when it comes to these last two columns, those are objects, right? Actually, those are strings, I'm pretty sure, not integer or a float. So we cannot directly just subtract like the drop times by request time. Just not gonna work because you cannot perform calculations when your data type is still string, right? You need to convert it to float first in order to be able to perform statistical calculations, right? So let's do it. This might be look a little bit more complicated, but promise me, I promise you guys that actually it's not that complicated. Okay, so let me do it by myself first, then I'll explain it to you step by step, so don't worry. So first, data request timestamp. Too lazy to type, why don't we just copy and paste it from here, also to make sure that we don't mistype it or do something stupid. Okay, so now we have data request timestamp. So now we need to convert it to date, right? Because we want to perform a calculation, that's why we cannot leave it to be as a string. We need to convert it to date. So pd equals pd dot to that time. PD is definitely an attribute of pandas, and to that time is simply just a command for converting this to date. Okay, and then it takes one parameter. The parameter is request timestamp, so we just need to copy and paste it, and we also need to give error equals to coerce. Oh, sorry, I misspelled it. It should be COERCE. Okay. Also copy and paste this, because we need to convert the drop timestamp to date. Not only the request timestamp, we need to convert both, right? So that's why we copy and paste it and then change it into like that. So okay, so now we're just going to calculate the difference, right? We want to know the duration, how long it takes you from, you know, ordering your Uber till finally get to the destinations. So let's name it diff. That's durations. So it's data drop timestamp minus data request timestamp. Okay. Then just display the answer here, data the diff. So when we create like data diff here, actually we are adding like one more column. The name of the column is diff, but it's actually just the durations, like how long it takes you from, you know, ordering Uber to finally get to your destinations plus. So what if we want to display like the first 8, because we don't want to like have very long output, so why don't we just display like the first 5 rows, right, to see like the bigger picture of what's going on here. Okay, so these are like first 5 rows. Just in case you guys haven't known yet, in Python the indexing starts from 0, so 0 is equivalent to 1. Okay, so it takes like an hour and 9 minutes, 50 minutes, 41 minutes, 50 minutes, and 52 minutes and 31 seconds. Okay, so I guess in average it's like less than an hour, mostly like less than hours. Yeah, okay, so that's how you know like the durations. Let me explain you a line by line, like so you guys will be able to understand like what's going on here. So first, you have data request timestamp. Again, previously this was a string, so you need to convert it to that time first. So you guys can perform the calculations. The same thing, the exact same thing with drop timestamp. You treat it the same as the request timestamp. It used to be string, and now it has been converted to date time. Okay, so error coerce is simply just like if else statement. So just in case it could not be converted to, then it display this message, right? Alright, then when you add this port, you are actually adding like mark column and you name it as diff. Actually it represent durations. If you want to change it into duration, it's completely fine. So it makes sense, right? When you want to get the durations, you subtract the time when you arrive in your destinations with the time when you order Uber, right? To know the full durations, like how long it takes you. Yeah, and then this is simply just to display like the first five rows of um, rows of the data sets. If you want to display like the first 10 rows, just change it into 10 and then you will get this. Okay, to keep it simple and short, I'm just going to display the first two rows personally. Okay, cool. So next, what we're gonna be doing here is simply just to do like further statistical analysis. Why don't we create like more blocks? This time we're just going to define variable durations as data div like this. And yeah, I'm actually curious, like how long, like what's the max and min. So let's do it. Duration max. We want to know like the maximum durations. Wow, 29 days? No, it doesn't make any sense. This has to be something like exception in data, or there's like something wrong, like weird stuff going on in the data. It just doesn't make any sense. It took you like 29 days to like from ordering the Uber to finally arrive in the destination place. So I guess we're just going to ignore this part. It just doesn't make any sense. What about the minimum durations recorded? Negative 148 days? Dang. It doesn't make any sense too, right? It doesn't make any sense. What about the median? Again, the data set from Kaggle is definitely not perfect. That's the reason why cleaning the data set before using it is very important to make sure that like these kind of exceptions or these kind of components of data that do not make sense and will skew our conclusions need to be taken away first, right? So uh, once we do the statistical analysis, data analysis, there is no part of the data that will accidentally skew or bias our results, right? So let's do the median. I think the median is going to be the most appropriate method. Okay, so the median. There's a reason why I use median here, not mean, because if we have data distributions, it's really like skew, like very far to the right or very far to the left. It will be better to just find like the middle value, which is median. So yeah, it makes sense. The median is 52 minutes. I think it's pretty accurate representations and pretty fair to claim that 52 minutes is the most common, the most frequent durations. Okay, let's do one more thing before we are done with this first data set. Why don't we just show like what's the most common or what's the most frequent durations by doing a value counts here. Okay, so copy and paste the code and write it down like this: value counts. Pretty much the same exact concept like we did before. Let's see and compile the code. Actually, I mistyped it, so I'm gonna fix it first. Then here we go. Oops, sorry, I mistyped it again, unfortunately. Let's see what's going on here. Okay, so the most frequent durations, it takes like 49 minutes for 49 minutes for passengers from ordering the Uber until arriving in the destinations, and there are like 40 trips that took like 40 minutes. And then the second one, like the second most frequent trip duration is 38 minutes. There are like 36 trips that took 38 minutes. Okay, so yeah, I think this is definitely way better accurate like more accurate representations of the data sets instead of using max or mean or average. It's better to just use median. Just in this case, unfortunately, the data is not clean. If I knew this, that the data needs to be clean before performing the statistical analysis, because I really want to avoid any results of this analysis being skewed, like very biased, something like that. So yeah, I think that's it for practice one. um I know that you guys might still get confused with lots of different type of functionalities here, but don't worry, we still have like practice data set 2. And hopefully by practicing another data set, you guys will be able to understand um easily and have better solid understanding. All right guys, I'll see you in the next video. Alright guys, welcome back to the course. So in this video, we're gonna be starting performing analysis for our second data set. So let's search the data sets that we're gonna be using. So actually I chose to use this one, IMDb Top 100 Movies. Completely different, unrelated to the previous data sets. Alright, so this is all about movies. Honestly, I'm a movie lover, so kind of interested and also excited at the same time to analyze this data. So let's click on this button, download. Okay, cool. So now it has been downloaded. I think it's still in zip file, so I guess I need to unzip it. Okay, so now we already got it. So let's start. Okay, here we go. I will create new file here. So new notebook. Okay, so too many tabs. So I'm going to close one of them because I'm not gonna use it anymore. All right, so let's name it first. So as usual, just name it using the name of the dataset, so it's easier for us to remember, I guess. IMDb movies. Let's name the file that way. Okay, so now let's start coding. Okay guys, exactly the same like what we did in the previous videos in the first dataset. So we already downloaded the datasets. Now it's the time for us to upload it on Colab. So exactly the same, from google.colab, import files, create a variable called uploaded, then files.upload, open and close parentheses. Okay guys, so we'll see. Now click on choose files and movies. Just open it. Okay, so now it has been uploaded and it's available to use. So let's see what the data looks like. All right, let's see the overview of the data. So as usual, import pandas as PD. That's the common practice. Data equals PD. Let's read the data using the pandas attribute, read underscore CSV. And this function takes one parameter, and that parameter is supposed to be the name of the file. So I guess we're just going to copy and paste this because I don't want to mistype it. Yeah, sometimes I mistype it, and then when I compiled, suddenly got error, and then I got really upset. Okay, so let's get the head of the data, see the overview of the data, I guess. Dang, what happened? Okay, so it seems like I mistyped it something here. So let's recompile it and see what's going on here. Okay, cool. So maybe if it's too long, you just want to see like the first 3 rows, just type in 3 there. Okay, cool. So this is like these are the first 3 rows of the data. Or maybe if you're curious and want to see like the last 3 rows, just change it. Let's replace the head with tails, and then see. So these three are the last three rows. Okay. All right, cool. So let's go back to head and then just leave it like this. All right, guys. Let's move on to another block and then get the info of the data as usual, because we want to know and understand like the type of the data, because we want to understand like what can we do with the data, right? Okay, so there are like 9 columns, right? Index is float, movie name is object, I'm pretty sure it's string, year of release object, category object, runtime object, genre also an object, IMDb rating is a float, votes is an object, and gross total is an object. Okay, cool. Let's see like how big is the data. So let's see like the shape of the data, right? Data.shape. See. Oh, actually, we don't need open and close parentheses. Just see. Okay, so it's actually pretty small data, right? Pretty small data. That's not surprising at all, since it didn't take too long to upload it. It didn't take too long to download it. So I already knew that this data is actually a pretty small data. Only like 9 columns with 99 rows, right? Compared like to the previous data set, we got only like 6 columns, but like thousands of rows, right? So yeah, actually I'm kind of excited to know that we're gonna be dealing with a smaller data. So just like it's going to be easier, and then it's going to be quicker to be compiled, I guess, due to the size of the data that's pretty small. I think that's it for the overview of dataset 2. I guess I'll see you in the next video. In the next video, we're going to be conducting analysis, kind of the same thing like what we did in the first datasets, but there are multiple different methods that I'm going to introduce to you guys. All right, so yeah, I'll see you in the next video. Bye. Alright guys, welcome back to the course. So in this video, we're going to start to explore the second data set. It's going to be fun, but also complicated at the same time. So let's start, okay? But again, you guys are in a better place, obviously, because you guys have learned from the first data set. So I'm pretty sure and pretty confident to claim that you guys already have like more solid understanding of what's going on. So I think the second dataset practice is actually intended for, developing and improving your skills to get even better. So without further ado, let's start. Okay guys, first of all, let's scroll a little bit up here and then see what's going on here in the dataset. So if I emphasize on this particular column, year of release, what if I have questions asking you, based on this data set, in what year there are most movies being released, right? Or in other words, like in what year there are highest number of movies being released, right? So actually, we can apply the same exact concept that we learned from the previous videos. So as usual, common practice, import pandas SPD, and then let's get the value counts here. Value dot underscore counts. So these functions take parameter. Well, actually, it's not a functions. Simply just this data takes a parameter of the name of the column, since we're going to be dealing with this particular column. So we're just going to copy and paste it right here and see. Okay, cool. That's really long output. Okay, so if, to answer that questions, 1999, 1994, and 1995, these 3 years have the most amount of films being released. Okay, but if you don't want to be dealing with this very long output, we actually can just just display, like, let's say the first 5 rows, right? Or like the first, like the top 5 years where there are like most movies being released. So okay, on 1995, 1994, and 1999, where there are like 5 movies released each year, and 2006, 2003, there are like 4 movies being released. Okay, cool. So I think that's it. Why don't we move to another part? So if we scroll a little bit up here, on the right side of the year of release column, there's a category column, right? So why don't we analyze in this data set how many different type of categories exist, okay? And then we are also going to be visualizing the data, so it's easier for us to see. Okay, so first of all, to answer the first questions, how many different type of categories exist? Let's write the code first, okay? Oops, I accidentally add like a code block in the different in wrong place. So let's start. Okay. I think we can just like copy and paste the code because it's going to be pretty much the same. But instead of having this year of release as parameter, we're just going to replace it with category. Okay. Okay, cool. So it seems like we have 7 different categories here, or 58, PG-13, PG, G, approved, pass, and GP. To be honest with you guys, I'm not really sure like what these last 3 mean, but if you're a movie fans, you might know this already. But if just in case if you have never seen this before, R stands for restrictive, meaning that that movie is only intended for people who are like above 21 years old, or 18 years old, depending on some countries. PG-13, meaning that that movie fall under categories of parental guide, but the kids also need to be above 13 years old to be allowed to watch. PG is parental guide too, but there is no like particular age requirement when it comes to PG. And G is general, meaning that anybody, even though you're like 3 years old, you still can watch it. Okay, so yeah, actually those are not very important. This is just like the main background of what's going on here. Just in case if you guys are not movie fans and have no idea like what's going on here, those are just a pretty common and general explanations regarding those 3 or 4 categories. Okay, so we actually already answered the first questions regarding like how many different type of categories. There are like 7 different type of categories, and why don't we just visualize the data so it's easier for us to see and understand what's going on here. So as usual, we need to import Matplotlib, pyplot, splt, then copy and paste this for plot plot.por nplt.co. It's a command to tell the program to show the bar plot. Okay, cool. So it seems like this bar here represent our like the restrictive movie. So like among 99 movies, 58 of them or like restrictive movies, right? Only people who are above 18 or 21 years old are allowed to watch the movie, and followed by PG-13 and PG and G. Okay, so if the question was asking you like what's the highest category here, the answer is obviously going to be restrictive movie, right? Like above 50%. Okay, cool. So let's move on to another topic here. Now let's add another block of code and see the runtime here. Okay, the runtime, or in other words, is durations, right? Okay, cool. So let's explore if there's anything that we can do with the duration here. Import pandas spd as usual, as our common practice. Let's scroll a little bit up to the data info to see. Oops, unfortunately, the runtime here data type is actually not a float or an integer. It's an object. I'm pretty sure it's a string too. So I don't think it's we're going to be able to perform any calculations unless we need to convert that to float first. I'm pretty sure. So let's do it. Let's convert it to float first. Because if we don't convert it to float, then we will never be able to do any. We will never be able to perform any calculations. Okay, so let's start. Um, Data. Why don't we just create like another column here called durations? Okay, durations. That's the durations of the film, the durations of the movie, equals data runtime, run underscore time, as type. Don't worry, guys. The syntax might be pretty new to you, so I will explain it to you later on. So don't worry, guys. Dot str string. Okay, cool. So now we're just going to print it just to test it out if it really works, if our code works as we expected. So duration, then head. I don't want to have like very very long output, so just skip like the first 3 rows. Okay, cool. Right. Okay, so let me explain to you guys like how this code works. Okay, so as we know previously from the data info, the the runtime column is a string, is an object string, not a float or integer. So we will not be able to perform any calculations unless we convert it. Okay, so then the question will be, why don't we just convert it right away? It's more simple. But when you scroll a little bit up here, there's a challenge here. There's an obstacle here. It's 175 minutes. Okay, so it's combinations between like, okay, you have like minute as a string and also 175 also as a string. Okay, but if you only have like 175 and then you convert it to float, then they'll be easy. But if you have like minute here, which is a string, and then you will never be able to convert minute to be a float because this is not number, right? Then you need to get rid of these 3 first, and minutes is like the last 3 digits, right? So that's why we use this particular code basically to get rid of the last 3 digits, because we want to get rid of the last 3 digits, which is the minutes, right? So now once you print this out, no minutes left on the back, right? So you only have like 175. So if you only have like 175 and like the whole word of the string is a number, then this is the right time for you to convert it to float, right? So let's convert it to float. Okay, so conclusion, like what does this code do is simply just to get rid of the last 3 digits, because we don't want the minutes, right? Because if we still have the minutes on the back, we can never convert it to float. Okay, let's convert it to float. Okay, so data, since we name it durations, we need to stay consistent with the name. We don't want to mess up the code here. Duration here again, we kind of like redefine the value of this column duration as type. So as type, it's a functionality in Python to convert to like different data type. Okay, just to test it out if our codes really work, we're also going to be printing the first 3 rows. Just make sure that it works. Okay, durations.head, maybe just 2, I guess, just do a little bit different here. Okay, cool, now it's float, so it has been converted to float. Okay, so if you want to do a study case, and if you're curious like why we need to get rid of the minutes first, why cannot we just convert it, why cannot we just keep this code and then directly convert it to float, right? Let me show you like how it works. It's not gonna work. So let me oops, sorry. um let me get rid of this. So you still have minutes, okay? And then you compile it. No, it gives us an error, right? So it simply just shows us that if you still have minutes on the back, you'll never be able to convert it to float, right? Because you still have string. Minute is still a string, and you'll never be able to convert it to float because it's not a number. It's a word, right? Okay, so let me fix it and then move to another part of the code. Okay, so let me fix it first. str 3. Okay, now it has been fixed. This code should work. Okay, cool. So now let's conduct our analysis. Okay, as usual, we need to import pandas spd. Then why don't we just define d as durations? Oh, sorry, data durations. Remember that actually we already created another column named durations. So we're just going to use this variable d. We define it as data duration column. It's the one that has been converted to float. So if we use like data runtime, it's still a string, and we will not be able to conduct the statistical analysis. We'll not be able to perform the calculations. But now, since it has been converted to a float, so we'll be able to perform the calculations. So let's get the mean, max, median, and mean of the durations. Okay, let's say mean equals to d dot mean, max equals, don't worry guys, I'm going to explain it to you like step by step how I got here. So median equals d dot median, and the last one I guess is the mean or the average equals d dot mean. Okay guys, so let's print the max, comma mean, comma median, and min, and see what's going on here. Okay guys, so the minimum durations of I'm supposed to put it this way so we don't misread it. Okay, awesome. So the minimum durations of the movies recorded in our dataset is 87 minutes. Okay, so it's like an hour of 27 minutes. The maximum durations of the movies that exist or recorded in our dataset is 238 minutes. Okay, so it's like almost 4 hours. And the median value of the durations of the movies in dataset is 130 minutes, or in other words like 2 hours and 10 minutes, and the average is 133 minutes. So when you see the median and the mean is very close, there is no like significant difference between mean and the median, it really means that the data is distributed evenly. Unlike the previous dataset where you saw like the max is like 200 something, the mean is negative 100 something, and that makes the data computation to be very biased. But this is a pretty good and clean dataset, I would say, because you have like the mean and median very close to each other. Really indicates, I think it's a pretty strong indications that the data is distributed evenly. So in this case, you can use mean, right? You don't need to use median, I guess. So yeah, that's my personal take on like what's going on in this data. This data is definitely cleaner compared to the previous data. So yeah, I think that's it for this video. I'm going to break into like 2 or 3 different parts for dataset 2, because I don't want you guys to watch the video for a very long time, so it has been like almost 18 minutes. So I guess I'll see you guys in the next video. Alright guys, welcome back to the course. So this video is going to be the second part of dataset to practice. Alright, let's begin. So let's start with genre. Okay, so in previous videos we have covered the year of release, category and runtime, and even convert runtime to float, right? Because like this column used to be a string and it needs to be converted to float first in order to be able to be calculated. Okay, so let's go to genre. Okay, so I'm kind of curious, like if I'm about to ask you questions, what is the most popular genre based on this data set? So why don't we just go ahead and analyze what's going on here? Okay, so I'm curious about what is the most popular genre, or what are the maybe top 6 genres. Okay, so let's write the code. As usual, we're going to use value counts, but in this particular case, we're going to use genre as the parameter, because we're going to be dealing with genre column, and since we don't want our output to be too long, so we're just going to limit it as 6 here. So we're going to put 6 as a parameter of the head functions, because we only want to display like the top 6 genres based on this data set. Okay, cool. So now I've compiled the code, and it seems like drama is like the most popular genre. Like 8 movies recorded in this data set are related to drama. And then what's the second one? Crime and drama. So like the second one, there are like 7 movies in this data set have combinations of crime and drama genre. Okay, cool. Okay, so it seems like it has already answered previous questions, but what if we want to get a better and more solid understanding of what's really going on here? Why don't we just create a, let's say, a plot to visualize the data? So as usual, I'm going to import Matplotlib as PLT, then copy and paste the code here, but we need to get rid of, no, actually we don't need to get rid of anything, so just add plot dot bar, open and close parentheses. And as usual, it's a good practice to add our code here. Again, as I mentioned before, it's still gonna work. It's still gonna work even if you don't have this code, but just a good practice to have it. So okay, let's see. Okay, so here's the graph. Drama. This board represents drama. There are like 8 movies. 8 movies related to the drama. 7 movies related to crime and drama. 4 movies related to actions, crime, and drama. Okay, cool. So like these are the combinations of genre, right? And then there are like 4. Okay, so the rest are 4. Okay, so now since we already knew like what happened with the genre here, we already knew like, okay, so drama is the one that dominates the dataset with 8 movies, right? So let's do a little bit different here. We're going to be using data group, but this time we're going to actually show the relationship of 3 different columns. Okay, so if you guys remember, either we did it earlier in the second data set, or maybe in the first data set, we used the data group attribute, but we only did it for like 2 columns. Like we were looking for relationship between 2 columns, but let's practice more complicated stuff here. Why don't we use this same attribute and apply it to like 3 different columns? because we want to see the relationship between three different columns. Okay, so let's see genre, and then we want to see the relationship between genre, IMDb rating, and category. Don't worry guys, I'll explain it later, but let's write the code first. Okay, so IMDb rating, and here's the third parameter. So yeah, just in case you guys haven't known yet, if you're talking about these functions, data group by, um, obviously you can add like more than two parameters, still going to work. So don't worry, even if you need like 5 parameters, still going to work. Okay, so let's compile the code and see. Okay, cool. So now we already got the output of this code. Let me explain it. Okay, so what I was trying to do here is simply just to see relationship between genre, IMDb rating, and category. Okay, so for example, if you're analyzing this data, okay, so this genre, for example, action and adventure, there are like two movies based on these particular genres, actions and adventure. One has 8.2 IMDb rating, and another one has 8.4 IMDb rating. And then the one that has 8.2 IMDb rating um, is PG-13, meaning that that movie is parental guide above 13. So like if you're like below 13, then it's definitely not recommended for you to watch. And another one is 8 point, and another one the movie that has like 8.4 IMDb rating has category of PG, right, or parental guide. Okay, cool. So yeah, that's definitely a pretty good practice to explore like what can you do with these functions. Previously we only had like 2 parameters, and now we use 3 parameters because we want to get relationship between 3 different columns here. Okay, so why don't we move on and see if there is anything that we can do with the IMDb rating, right? Because we knew that the IMDb rating has already been um, float, so we don't need to convert. We don't need to convert it to float, right? Because if the IMDb rating is still a string, then it's necessary for us to convert it to float, but it's already a float, right? So we can just perform calculations or yeah, do anything without having to convert it prior to our actions. Okay, so miss unfortunately I add like a wrong code block here. So okay, let's do it. Import, I don't need import pandas spd again. It's not necessary guys. So let's start. We actually want to sort values of IMDb rating. Okay, we want to display like the output needs to display movies based on the highest IMDb rating. So let's do it. So probably you guys have never seen this code before because we didn't really use sort attribute in the first data set practice. So maybe this is pretty new, but don't worry. I'm going to explain it later. Okay, so IMDb rating. Again, this functions takes an argument of the name of the column. So since we are going to be analyzing IMDb rating, because we want to sort the values of IMDb rating from like the highest to the lowest. So we're going to write down here ascending equals false. Okay, then dot group by, because we want to display the false twos here on the display. So and we don't want our output to be very long, so we're just going to get like the top 5 here. So we're going to put 5 here as a parameter of our head functions. So let's compile the code and see what's going on. Wow, it seems like there is an error here. Let's see what's going on here. Okay, so it's supposed to be sort values, so it was syntax error. But again, guys, when you get an error, don't be panicking. So it's actually good for practice, like you knew like what's going on, like what you did wrong. So next time you can like avoid that mistake again, right? You can avoid that same mistake again. Okay, so that's cool, right? So basically, the output displays the movies based on the IMDb rating because we sort the values from like the high to low, so it really displays movies with the highest all the way down to the lowest. Okay, if you want to see like the lowest, maybe you can just use tail here. So you're so the output is going to display like the last 5 rows, like the lowest one, which is this one. Okay, so let's go back and then leave it like this. Okay, so let me explain you the code, like how it works. So data sort values is attribute of pandas too. It takes one argument, the column that you want to sort. So in this case, we are sorting IMDb rating based on the highest rating to the lowest rating. So that's why we put this as an argument of the as a parameter of these functions. Then ascending false. Ascending means from low to high. So it's kind of like a boolean variable, since ascending means like from low to high, but we want to sort it from the high to low. That's why we put false here. But if we actually want to do the exact opposite, if we actually want to sort the values from like low to high, then ascending is going to be equal to true. Okay, and dot group by votes, because we want to display the votes here, um, and head a 5, meaning that actually we just want to display like the top 5 here, the top 5 movies with the highest IMDb rating. Okay, yeah, hopefully my explanation makes sense. I really apologize if I confuse you guys. So let's move on to another part here. um Actually, we're going to be doing a lot of data visualizations here, but the video has been 12 minutes already, so I think I'm going to break it down to like another video, so the video is not going to be that long. Okay, so guys, I'll see you in the next video. Next video, we're definitely going to be doing lots of data visualizations using Matplotlib. We're going to be generating bar plots again, or even scatter plots. Okay, guys, I'll see you there. Welcome back to the course, guys. So this video is going to be like the last part of dataset to practice. In this video, I'm pretty sure it's not going to be a very long video, because we only have like 2 or 3 practice left. So in this video there will be lots of data visualization. So yeah, I mean, if that's what you've been waiting for, then this is the video. Okay, so first of all, let's scroll up a little bit and see like the last columns of this data sets, which is gross total, right? So if you guys are not really familiar with movies, gross total is the earning, right? The earning from the movies, where it's like from sponsorship or selling tickets, stuff like that. Okay, so in previous video, we actually sorted the data set based on the IMDb rating from like the highest IMDb rating to the lowest, right? So let's do a little bit different here. Actually, we still use the exact same concept. However, let me import pandas SPD first. However, we want to do a little bit different in this case. We want to sort the movies in the dataset based on the lowest gross total to the highest gross total, meaning that we want to sort, we want actually to display like the movies, like the movies with the lowest, like the top 5 lowest gross totals. Okay, so we're just going to copy and paste the code because the concept is exactly the same. We just need to change the parameter since we are going to be dealing with gross total columns, so the parameter is going to be gross total, obviously. And since the since ascending means like from the low to high, and then if you remember, reason why we have false here in the last video, because we want to do the exact opposite. We want to sort the IMDb rating from the highest to lowest. That's the reason why we have false here. But in this case, since we want to sort the gross total from the low to highest, from the lowest to highest, then ascending is going to be true, right? Because ascending is from the low to high, and then this is exactly what we want to do. So yeah, it's definitely true. Oops, I spelled true incorrectly, but I have fixed it. So now let's compile the code and see what's going on here. Okay, cool. So now this is the display of the top 5 lowest gross total. Like the name of the movie that has like the lowest gross total, only like 20,000. Again, I have nothing against this movie, so yeah, don't get me wrong here. I'm simply just exploring the datasets. I have nothing against this movie. So movie name. So if you see like this, City Lights only has like 20,000 gross total, and the second lowest gross total is Modern Time, only like 160,000 US dollar. I'm pretty sure the currency is in US dollars. What a coincidence! Like the third lowest gross total is third. The name of the movie is The Third Man's, and then in this data set it has like the third lowest gross total. What a coincidence. Okay, anyway guys, let's start the data visualization. So okay, I'm going to prepare the Matplotlib here. I'm going to import Matplotlib first because we're going to be using actually Matplotlib. Okay, so we're going to be using Matplotlib. We're going to be making scatter plot. Okay, so let's discuss like what actually we want to see from this data set. I'm kind of curious. I want to ask these questions. What if we want to know the relationship between gross totals and IMDb rating, whether it's directly proportional or what, or inversely proportional, but it's very unlikely to happen, right? Yeah, my initial hypothesis, the relationship between gross total and IMDb rating is directly proportional, meaning that, hey, in most cases that if you have very high IMDb rating, then the gross total is also going to be very high, and that's the opposite. If you have like low, very low IMDb rating, then the gross total is going to be low. If that makes sense, right? Like IMDb rating represents the satisfactions of the audience, right? I mean, if you love the movies, if the movies is great, if the movies is fun to watch, then the IMDb rating is most likely to be very high, and that's the opposite. And here is my initial hypothesis before creating the scatter plot. I think if the movie is high, if the movie has a high IMDb rating, then it corresponds to like a relatively higher gross total. But again, there are like some cases where the IMDb rating is low but the gross total is high. It's possible, right? Or the opposite, when the IMDb rating is high but the gross total is actually not that high, right? It's possible. So let's try to scatter plot to visualize the data better. Again, in the scatter plot, if you guys haven't done yet, we need to have like two parameters, which is x and y. Okay, so for the sake of simplicity, I'm just going to use x and y. So x represents the horizontal axis, and in this case, x is going to be gross total. Okay, so we're just going to use it, put gross total as a parameter. And then since we don't want to be dealing with like very large output, so we're just going to display like the last 5 rows, right? Last 5 rows meaning that you only want to display is like the top 5 movies with like the lowest gross totals, right? Or in other words, you want to display like top 5 movies with the lowest income revenues, right? Okay, so the y represent the vertical axis, and the parameter is going to be IMDb rating because that's what we want to be comparing. We want to see a relationship between gross total and IMDb rating. The same thing here, tail 5, not Okay, cool. So let's create the scatter plot. PLT as usual. If you guys knew that PLT is an attribute from Matplotlib, and you scatter here, and then scatter functions takes two different parameters, x and y, which we have declared on the top here. And as usual, plt.show, and let's see like the scatter plot. I'm really curious, guys. Okay, cool. So yeah, you know, it's kind of weird when you see like the last row here has 171.48 million. I think this is an exception. The data is not really clean, so let's ignore these exceptions. Let's focus on these four points. Okay, so if we analyze this scatter plot, okay, the movie which has like the lowest gross total, which is City Light, has 8.5 IMDb rating. Okay, if we compare it to the second movie, I don't like which movie is that, but it has like 8.3 if I'm not mistaken. Yeah, it's 8.3 rating, and it generates like 34 million. And another movie here with only 8.1 IMDb rating, it generates 16 millions, right? Another one here, 23.3 millions, it has like 8.5 IMDb rating. So I guess the conclusion here from the scatter plot is it's definitely not fair to claim that the highest the IMDb rating, meaning the highest income revenue, maybe that's a pretty accurate claim for most cases, but not all the cases. Okay. So here's the evidence. If you see like these movies, it generates like $20,000 only, but it has like 8.5 IMDb rating. Meanwhile, there's another movie here. I don't know like what's the name of the movie. It generates like way more money, right? Like 34.4 millions, but it has like lower IMDb rating. Okay, so I guess my initial hypothesis was not very accurate, but again, that's the beauty of statistics, right? You create an initial hypothesis, and then you test it out, and you find out like, oh, okay, actually it's not that accurate. This is the evidence, right? Okay, so let's move on to another part here. We're still going to be making a scatter plot, but in this case it's going to be like different scatter plot. So let me import the Matplotlib, and to save time, just going to copy and paste here the Matplotlib. Okay, so let's see what we can do here. Actually, I've just realized, guys, that if we scroll up a little bit here to the data info, I knew that the gross total is still a string. The gross total is still a string, okay? So since the gross total is still a string, then it means that you cannot do a calculations. Again, I'm not planning to do any calculations here. I'm not planning to do like min max min here, because we already did it previously. However, it's a good practice, you know, to like convert it to float first, or maybe just get rid of the million first. Okay, so let's do it. So data, we're actually just going to create like another column here called gross. It's going to be exactly like gross total. It's going to be exactly the same as gross total. However, we're just going to get rid the mil, or the m here, right? This m here. So okay, so it's going to be, I mistype it always, gross total. Okay, dot s type. Pretty sure you guys already saw this multiple times using this attribute, and let me explain it later, but write the code first. Oops. Okay. So reason why I kind of like slice one and negative one here, because I want to get rid of like the first and the last character. Okay, so when you see like 23.34 million dollars, I want to get rid this part, like the dollars part, dollar signs, which is the uh first digit, and also like the last one, like the last character here, which is the million, right? I want to get rid the first character, which is the dollar sign, and the last character, which is the million. That's why I have like one and negative one, because I want to get rid of it, right? Okay, so let's define x. So x is going to be that gross. This is the new column that we've just created here. Okay, so in this column, it's still going to be exactly the same like gross total. However, we've already get rid of the dollar signs in the front and the million signs on the back. So let's see. And in this case, we want to do a little bit different. We actually want to just display like the top three movies with the highest gross total. That's why we use head instead of tail. And let's define the y variable, which is data IMDb rating, right? IMDb rating, also head, and the parameter is going to be 3. I don't want the outputs to be too long, so let's define it that way. Okay, so let's create a scatter plot, plt scatter. Okay, and input the parameter, which is x and y, which are x and y, and then plt.co to give a command that we want to show the plt the scatter plot. Let's do it. Let's compile this code. Okay, cool. So let's do like the exact same analysis. Okay, let me scroll up a little bit here. Where is it? Okay, it doesn't really matter. If we see the movies with the highest income revenue, movie with the highest gross total, I don't know like what the name of the movie. I don't think we should care either. It has like 200. It generates like 290 millions, right? 290 millions. And the IMDb rating is 8.7. Meanwhile, there's another movies that generates like 130.7 millions. It only has like 8.6. Okay, it makes sense, you know, like these movies has a higher IMDb rating, and also like generates like higher gross total. Okay, it makes sense. But if we see this movie, it generates like 134.97. Let's round this number up. Let's say it's 135 million. So when it comes to your gross total, definitely this movie has like lower gross total compared to this movie. However, the IMDb rating is very high, really high, like 9.2, guys, compared to this movie. These movies generates like almost twice income as these movies, but the IMDb rating is only 8.7, and this movie which only generates like almost like half than this movie has like 9.2 IMDb rating. Okay, so it really convinced me even more that our initial hypothesis was not really accurate. Okay, that's not always the case when the IMDb rating always indicates like higher gross totals, right? Or the exact opposite. It doesn't really indicates that the lower IMDb rating always corresponds to like lower gross totals, right? Okay, cool. Yeah, I think that's the end of data set to practice. Let's write down the conclusions here regarding the data gross total versus IMDb rating. This is one of the most fun challenge here to like not only analyze data but also visualize and be able to like drive a conclusions, right? That's what we call as an acumen, where you can not only like analyze the data but also take insight from the data. So let's write down what we got here. So first, oops, I need to have like the comments value, the comment sign here. Okay, so first, the initial hypothesis was incorrect, not incorrect, maybe inaccurate. Okay, gross total is not directly proportional to IMDb rating. There are certain cases where you have high IMDb rating but with lower gross total, or maybe the exact opposite. What's the exact opposite? You have lower IMDb rating but with higher gross total, right? So yeah, I think that's the conclusions of this data set to practice, especially when it comes to relationship between gross totals and IMDb rating. I really hope you guys enjoyed. We still have like 2 or 3 different slides left in this course. So yeah, I will see you in the next video. Welcome back to the course, guys. So this is part of the conclusions of the course, data analytics common practice. If you guys interested in exploring more datasets on Kaggle, after analyzing these 2 datasets, there are still lots of datasets available on Kaggle. So if you guys are interested in and would like to explore more datasets and would like to do on your own and applying and test out your knowledge that you gain from this course, then this data analytics common practice guide might be useful for you. So yeah, let's begin with the first one here, identify problems, right? So that's the very first thing that we need to do before doing anything else, to identify problems. You guys need to ask questions like what things that we're trying to solve, right? Things that we're trying to achieve, objectives that we're trying to accomplish here. And sometimes the question itself is too complex, right? The question itself is too broad. So it will be very helpful for you guys to just break it down into like smaller and more simple pieces. Even though like from like one question you break down to like 5 different pieces and look, oh, that's so many, but that's fine, guys, because you want to make sure that you're able to understand like what you're trying to solve, right, easily. And you want to make sure that you know what you're trying to find in the data, right? What you're looking for in the data. So that's the identifying problems. Then after identifying problems, after knowing and understanding completely like what you're trying to solve, what you're trying to find in the data, then the next step will be cleaning process, right? If you're lucky, then the data set is clean and then there's not much thing that you need to do. But most of the times that's not the case, guys. Most of the times data is very dirty, unstructured, and unorganized. So most of the time it's necessary for you guys to do lots of cleaning, right? And making sure that the data set is ready for the analysis process. One of the example is like okay, you type in data info and then you got there are like several columns here. They're actually in string, right? However, you will need to perform statistical calculations. Maybe you want to get the mean, median, max, min, or something like that. But again, you won't be able to perform those statistical calculations if the data type of that column is still string. Then you have no other choice besides converting that data, that column in the data sets into float first, or maybe integer first, before performing the statistical analysis, right? That's just an example, one of the examples, right? One of many examples. Or the other example might be, okay, so you have a data set here, and then you find the max and mean. The max and mean of the data doesn't make any sense, like what we found in the first data set, right? If I'm not mistaken, like one skewed 34, like to negative 145, and then another one skewed 34, like negative 100 something. Just doesn't make any sense, right? If you guys remember, it's from like our Uber dataset, which is our first dataset. It doesn't make any sense when it takes you like 200 days from ordering your Ubers to finally arrive in your destinations, right? So yeah, that might be exception. So you need to like exclude that data. But again, if you're talking about the professional settings, then you need to make sure you ask your supervisors or your managers regarding that data. But if you're just exploring data set and see like something that doesn't make any sense like that, don't don't be panicking, guys. I mean, just exclude that part, because it will definitely skew your uh, conclusion, your analysis conclusion, or it might get biased. Or even if you keep that data, instead of using mean, maybe you need to use median, right? The middle value. Because if you use mean, then that extreme part of data that's not distributed evenly, like that negative 100 something, will definitely affect your mean, right? So yeah, that's one of my advice regarding data cleaning. Then the next one is conducting analysis, right? This is the fun and the most challenging part. Like this is the main part of our job, conducting data analysis. Yeah, I knew that this might take a while. It might take very takes a while, take a long time to do, but it's better to simply just break down into like smaller and more simple pieces, and do it one by one, guys. Don't do it like once together, because like it will make you to be not as productive as you supposed to be. Just try to solve the questions, try to solve the problems one by one. So yeah, that's what I said here. This is the main step, obviously. um, and again, executing certain actions definitely might take you like extra efforts, but that's the part of our job. So like this is like the main one, guys. Then the next one will be visualizations. Okay, so after conducting analysis, you got the answer to that question, you got things that you're looking for in the data, but sometimes it's kind of abstract, or maybe it's not abstract. Maybe you know like what's going on in data. You know like what's the answer to this. What's the solution to the problem here. But it will be better if you visualize data, right? Whether you need to generate scatter plot, linear regressions, or bar plot, or histogram, or whatever data visualizations type you choose, depending on the type of data, the type of things that you're looking for. So in this course, we use Matplotlib, but you can also use Seaborn or other Python libraries regarding data visualizations, right? So yeah, it's going to give us like a solid understanding of what's really going on, right? And it's also going to help us if we need to explain it to people who are non-technical, people who come from non-technical background. We need to be able to translate like what we encounter and what we found in data, and try to explain it to them in a language and a explanations that can be easily understood by those people, right? Okay, then now the last one is acumen, or maybe you have heard about like business acumen or something like that. So acumen meaning that you need to have the ability, as a technical person, you need to be able to explain like what you got, like your findings on the data, your findings, what you discover with the data, to people who have very limited knowledge in statistics, people who have very limited knowledge in data analytics, right? You need to be able to convert or translate like your findings and even your solutions to the problem in a non-technical language. That's basically what acumen is, right? So I said here, you need to be able to explain your findings to the people from maybe different department, people who know nothing about data analysis, right? So yeah, that's pretty much it, guys. Data analytics common practice. I really hope you guys pick at least like 2 or 3 other different data sets from Kaggle and then practice on your own, applying knowledge and skills that you've learned in this course. And yeah, also applying like this data analytics common practice guide along the way. Okay, guys, I'll see you in the next video. There is another video here related to like Kaggle data competitions. All right, I'll see you in the next video, guys. Welcome back to the course, guys. This is the last video for this course. Let's talk about Kaggle data competitions, right? This is pretty fun to be brought to discussions, I guess. So yeah, Kaggle has been regularly hosting data science competitions. To find out more, you guys can click on this link. Okay, just go to this link. Just click on that link. So almost every competition is price ranging from 25K to 100K. That's like the normal range. So that's like a huge money for myself. So if you guys are interested in data science and like to challenge yourself to improve your knowledge and skills in data science and like to get prize, I mean, if you do very well, then yeah, it's definitely worth a try, even though the competition is very competitive, right? There are like lots of people who are really good at it, and again, it's, the chance of winning is relatively low. But again, you guys need to feel confidence and try it, right? You'll never know if you never try it, right? Yeah, it's very competitive, but definitely not impossible to win. And yeah, so the question might be like how to explore and participate in Kaggle competitions. Okay, so first of all, click on this link. Now it will directly bring you to this page. Okay, competitions. You can explore, like there are like many different competitions here on Kaggle. So you scroll a little bit down here, and then you see the sections. It says active competitions, and also like recently completed. So recently completed competitions, meaning that the competition has been completed, so you cannot enroll anymore. Now it's been completed, so just like waiting for the winners to be announced, right? This is community competitions. What else? I think that's it. So what you guys need to do is scroll up a little bit here and then go to the active competitions, meaning the competitions are still active or still open if you want to enroll, right? So there are like many different competitions here. You can see there are like 2 important things that you need to see. The first one, obviously the price. If you're crazy about money, you see this has like $100,000, 60,000, 55,000, 55K, 50,000, yeah, 55K dollars. Scroll down a little bit here, 55, I'm sorry, 50, 50, 30,000. So I don't even know what that mean. So yeah, just click on this if you're interested in and see like what's the challenge here. Obviously it's going to be like very hard problems that need to be solved, because I'm pretty sure like they're willing to spend this amount of money because they knew that they will get the value from you guys. Like the code that you're going to write, the solutions you're going to provide is going to generate like lots of values that worth like $100,000. That's the reason why the reason why they are willing to spend this amount of money, right? And then the other thing that is very important for you guys to see is the deadline, right? Because you don't want to miss the deadline. So look at this. The deadline is, if I'm not mistaken, it's March 2nd, 2023. So we still have like 2 months left, I guess. The same thing like this. So like a month ago, meaning that you have like approximately a month left, right, to do the competitions. Okay, so it's just click on it to explore more, read the descriptions, the context here, and then the evaluations. So it's simply just a guideline like how to submit it, and timeline. Okay, so this is a start date when the competitions was launched, and the deadline. This is very important. The final submissions. Okay, these two are also very important. The entry deadline, and the team merger deadline, right? And this is the price. Okay, so 100,000 going to be divided into like five different categories here. If you win like the first place, you're going to get like 50K. That's huge. This is the code requirement, right? You need to comply, your code needs to be comply this requirement, because if not, then they might just ignore and like not gonna take your code. So yeah, it's very important. And this is the data set description. You might need to spend like, an hour, I guess, to make sure you really have a good and solid understanding of what's going on in the data set and what you're trying to solve. Is sample submission, just click on it and then see, just skim it, see like what's the expected submissions, expected outcomes from these competitions, right? So if you know like what's the competition's requirement, like what they're expecting from you based on this example, then at least you will have like a pretty good overview, like what you need to do, what needs to be done, right? So these are the codes, discussions. Again, even though this is competitions, but the beauty of Kaggle competitions, you're still allowed to discuss, problems here, but I don't think you will be allowed to like share your solutions or asking someone to share your solutions, because again, this is competitions. However, if you're kind of stuck on like one particular steps, then yeah, um, as long as it's not like the main solutions, then maybe you can like share or have a discussion here. But again, in order to make sure that you comply with the competition's regulations, you don't um, make sure you don't break any rules. You need to make sure first before making any posts in the discussion forum. This is the leaderboard. Okay, so I think the beauty of this sessions, you can track your score here. So you know like where you are right now. And last but not least, this is the most important thing. When you join, before joining the competitions, you need to read like the rules, right? You don't want to break any rules, right? You don't want to um, submit your code and then actually you have very high quality and very valuable um, codes, but you broke the rules, so they will exclude you, something like that. You don't want that to happen, right? So yeah, that's Kaggle competitions. I think if you are interested in Kaggle data science competitions, and it's definitely worth to try it, right? You'll never know. Maybe you don't win today, but you can win in 3 months. I don't know, right? You will never know if you never try it. Again, disclaimer: I'm not affiliated with Kaggle. I'm not sponsored by Kaggle. I just regularly use Kaggle as a data science learning platform. I've never participated in Kaggle data competitions yet. However, I'm planning to participate in the future, maybe in the next couple of months, since I'm pretty busy lately. So yeah, I'm definitely interested, to be honest with you guys. But I'm not affiliated marketer for Kaggle, anything like that. It's simply just a pretty good platform to use. Okay, guys. Anyway, thank you so much. I really hope to have another opportunity to meet you again in another course. Okay, so this is just like my second course on Udemy. I'm planning to make like another course maybe in the next couple months. I'm thinking about making a course related to SEO and Google Ads, like search engine optimizations, choosing the right and accurate keywords for Google Ads or maybe even TikTok ads, right? Or maybe if any suggestions, just let me know in the comment sections down below. Anyway, I'd like to congratulate you for completing the course. Definitely not an easy course, but thank you efforts. But um, you get here. Congratulations, my friends. Congratulations, massive congratulations to you. Again, after completing this course, this is just like very basic course, so um, we should have not like very high expectations on winning Kaggle competitions or anything like that, anything crazy like that. But this is definitely a good and solid basics that we all need to have in order to excel in this field, right? Anyway, I guess once again, Thank you so much for trusting myself. Thank you so much for your trust to learn with me. I really hope to see you in another opportunity or in another course. Bye. Wish you all the best.